Hello everyone. This is going to be the fourth video solving model examination. The first question for today, it says, which one of the following correctly describes the difference between distance and displacement between 2 points? So this time, as you see here, we are asked to compare distance and displacement. Mostly students, they think distance and displacement are the same, but there are real differences. The best difference is shown in the figure here, as you see. For example, you can consider the point A as your home and the point B as your school. So when you are moving from home to school, the car or the transportation system may go in this pattern, as you see. Okay, there might be zigzag. That's going to be the actual distance that you moved. But if we try to go just directly from home to from the home to school directly, if there is a way, it's going to be shorter. So always the displacement is the shorter one, and it has direction. Maybe your school will be northern from your home, or to the south direction, or to the east. It depends. But anyways, there will be direction in case of displacement. But in case of distance, direction doesn't matter. Left, right, anywhere, the actual length that you moved. For example, from home to school, if you move and if you get back to home, the displacement is going to be 0, because you go right and then you get back left. That's going to be 0 displacement. But the distance will be, both trajectory will be measured. So the real comparison between distance and displacement, as you see here, it says distance is the length of the path traveled by a body while moving from initial position to a final position. As I said before, when we come to displacement, it is a shorter distance between initial position and final. And distance is scalar. Scalar means it has no direction. But displacement, it is vector, Distance always positive. Displacement, it might be negative sometimes. In case of in the XY coordinate plane, if you consider, if someone starts from the 0 position and go to the left, the displacement will be considered as negative. That negative implies that person is moving to the left direction. But distance, it measures only the actual length. So displacement, it can be negative sometimes, but distance can't. The total distance covered is equal to the algebraic sum of all the distances traveled in the direction it says. And in case of displacement, you may subtract, as I said before. If you go from home to school and if you get back to home, the total displacement might be 0, because you may go like 5 kilometers, and then when you get back again 5 kilometers, but in different directions, so they will cancel each other when you are adding. So these are some of the comparison, and both of them, they will be measured in meter. Their SI unit will be meter, because lengths, both of them are lengths. So which one is the correct answer? Let us choose now. A, distance is vector, it says. No, the vector one is displacement, we said. And distance is defined as displacement in a fixed direction. No, distance, actual length only. But displacement, we can say distance in a fixed direction. Okay, distance plus direction will give us displacement. But distance, it is not the same as displacement plus direction. No. C, magnitude of displacement can be greater. No, magnitude of displacement, it can be shorter even. As I said before, if you go from home to school and from school to home, the displacement, the magnitude, it might be 0. But distance, okay, both there will be added, like 5 kilometers from home to school, and from school to home, 5 kilometers will be added in case of distance. When you go to the next one, D, distance can be greater. Yeah, that's correct. Distance can be greater, so the answer will be D. Next question. The temperature of 0.5 kilogram object raises from 10 degrees Celsius to 13 degrees Celsius. What is the heat energy absorbed by the object? Okay, we increase the temperature of an object. The mass of the object already given to you. So what will be the heat energy absorbed by the object? Remember the formula. In case of specific heat capacity equation, if you know the specific heat capacity of a substance, you can calculate the amount of heat energy required to any mass of by any temperature change. So for this object, the temperature initial is given to you 10 degrees Celsius, and the final or T2 is given to you 13 degrees Celsius, and the mass of the object also given to you 0.5 kilogram, and the C also given to you, the specific heat capacity, which is 480 joule per kilogram degree Celsius. It says this, everything is given. So what the formula? The heat gained will be Q is equal to C times mass times change in temperature. Mostly our book use Q as for temperature, I mean for heat. Some books they may use EH. Therefore, the C is a specific heat capacity, that is 480. Let me ignore now the unit all because it's appropriate unit. And I'm inserting in the formula, but let me change it the color because to make it somehow clear. This is the formula I'm applying. C times change in temperature, mass times change in temperature. Yeah. So the mass is 0.5 multiplied with the change in temperature, means I have to subtract. This is a change in temperature, which is 13 minus 10 will be 3 degrees Celsius. So I'm going to multiply by 3. Then when I multiply, you can cancel the 0 and ignore the point here. Okay, because there is last 0, means the decimal point will be removed. And then multiply. 5 times 3 will be 15. Then multiply 15 by 8. How to multiply? You know, 48 multiplied by 15. 5 times 8 will be 10. You have 1. 40, you have 4, and 5 4 24, and again 1 8 8, 1 4 4, then add it 0 12, we have 1 7 20. So that's going to be 720 joule. The answer is going to be C. Okay, once let me repeat what I did here. Temperature of 0.5 kilogram object raises from 10 to 13, means that is a change in temperature, which is 3, and the mass also given to you 0.5 kilogram, and the specific heat capacity of the object also given to you 480 joule per kilogram degree Celsius. So what is the formula? Before the formula, I try to state what does specific heat capacity equation means. This is the equation of specific heat capacity. Q is equal to C times mass times change in temperature. Okay, let us continue to the next question. When you go to the next one, a bar magnet and a solenoid with an iron core, that means electromagnet. Now the question is discussing about bar magnet and electromagnet. They are different in that electromagnet are characterized by the traits, unlike the bar magnets. So what is the main difference between electromagnet and bar magnet? Let us try to see. So as you see here, bar magnets and electromagnet, it's compared here. What does it say? Bar magnet is permanent. It's permanent forever. Okay, we cannot change it. Bar magnet, it is naturally existing, but electromagnet is temporary because this one is man-made. And the second point, bar magnet, it produces a comparatively weak force of attraction, but electromagnet, it produces a very strong magnetic force. And the other comparison, the strength of bar magnet cannot be changed. We cannot change the strength of bar magnet. If it is once strong, it will be strong forever. If it is weak already, it's going to be weak forever. But when you come to electromagnet, since it is human-made, the strength of an electromagnet can be changed by changing the number of turns in the coil or by changing the current passing through it. Okay, if the number of turns of the coil increases, the magnetic field might increase, and the same if the current increases, also it increases. And the other comparison, polarity. When you come to bar magnet, once the north pole is here, for example, if the north pole is found here, if the north pole, in case of bar magnet, if the north pole is here, the south here, we cannot change the pole as it is, it will remain forever. But in case of electromagnet, we can change the polarity by changing the direction of the current, as you see here. So which one works? Electromagnet are characterized by dash temporary magnetism and changing polarity. Yes, it's temporary because we are talking about electromagnets. And temporary magnet, yes, we said already, it's temporary, here it is. And at the same time, changing polarity, yes, the polarity of electromagnet can be changed, it says, this statement, can be changed. So the answer is going to be A. The others, electromagnet temporary and fixed polarity, it says no. And permanent magnet, it's not permanent, also permanent, it says no, doesn't work. So the answer will be A. The next question, it says 90 kilogram object is taken to the surface of Mercury, where acceleration due to gravity is 1/3 that of the Earth. Hence, the mass and the weight of the object on Mercury are dash and dash respectively, it says. There is a mass. The mass of the object is 90 kilogram. This mass, whether it is measured on Earth or in Mercury or in Jupiter, wherever it is, the mass is always the same. Mass will not be changed. Mass is same everywhere. That means the mass will be 90. 90 kilogram will remain everywhere. So the answer must be either A or B, because here 30 says doesn't work. So the mass will not be changed wherever it goes, but the weight changes, because remember, weight means mg. The gravity matters. Where is the object measured? In Mercury. The gravity of the Earth is already given to you 10. So the mass is already 90 times. What about the gravity? I'm not going to take the 10 because it's on Mercury, gravity of Mercury. I'm talking about gravity of Mercury. What is gravity of Mercury? It's 1/3. So I'm going to take 1/3 of the 10. Because gravity of Mercury, okay, it is the same as gravity of Mercury is equal to 1/3 of gravity of the Earth. Therefore, let us multiply. When you multiply, you can simplify here. How? By 3, 1. This by 3 will be, 30. 30 times 10 is going to be 300. 300 Newton will be the weight. The weight where? The weight on the Mercury, not on Earth. So the answer must be B. Good. It's a very nice question. Let's continue the next one. The next one, it says, which one of the following is correct about lenses? Which lens? Convex, concave. Concave, again convex, it says. So that we need to compare and we need to recall the comparison between concave and convex lens. So as you see here, convex lens, as you see, it looks like this one. Okay, and concave will be, it's a kind of bend at the middle, and at the top it will be fatter. But convex lens at the end, it's going to be needle-like, but at the middle it's going to be fatter. So this is the way how does if parallel rays are coming. These are incident rays, incident ray. They are parallel all here also the same manner. So how does it goes after reflecting or refracting on the lenses? In case of convex lens, as you see, it says it is thicker at the center than at the edge. Yes, as I said, at the middle it will be fatter, and it has real focus. The focus is real. Here it is. This is a real focus, and it converges a parallel beam of light on refraction through it. It converge. Converge means all the light which comes parallel, it become collected and pointed at some point at the focus point. So that means it is collected, it converges. That means it comes together at some point. But when you come to concave, as you see, the lights, okay, are scattered. So it is thinner at the center and at the center than at the edge, and it has virtual image and virtual focus and virtual image. Which one? The concave one. Concave lens, it has virtual focus and virtual image, and it diverges parallel beam of refraction. When parallel beam of light coming, it will diverge. So A, convex lens diverge. No, convex, it's not diverging, it is converging. Again, B, concave lens form real image. No, it must be virtual, as you say here. The focus is virtual, also the image are virtual actually. C, concave lenses are converge. No, again, concave lens, they are not converging, they are diverging, as you see, they are scattered. D, convex lens converge the light. Yes, that is true, we said it already. So these are the way how we can compare. Let's go to the next question. Okay, the next question, it says, in a hydraulic press, the small and the larger pistons have area of 5 centimeters square and 250 centimeters square respectively. If a force of 30 Newton is applied on a small piston, what load can it lift up? First of all, try to recall a hydraulic press. How does it look? Hydraulic press means the image as you see here, it looks like this one, the best way of explanation. So this time there are two pistons here, smaller area and larger area here. So if you press this part by pressure, like if you press it, pressure will be exerted here, but that pressure will be distributed equally everywhere. So the pressure which will be applied here is the same as the pressure which comes here. So it says pressure is exerted on fluid in a small cylinder, usually by a compressor, mostly. So Pascal's law, what does, he is a physician, he's a Pascal, his name is Pascal. What does he say? What did he say? Pressure is exerted equally in all parts of an enclosed static fluid. Static fluid means the fluid is at rest, it's not moving, and it's enclosed at the same time. So think of that. The pressure here, P1, is the same as the pressure here. But remember, pressure is equal to force over area. That means pressure 1 means it's the same as F1 over A1. It must be equal to pressure 2 means F2 over A2. So here smaller area and here larger area. So the second force must be larger because the ratio to become the same. That means we are multiplying the force. We are applying a force here and pressure is exerted on the fluid, but a small amount of force we apply. So though the pressure is the same, it is exerted over a much larger area, giving multiplication of force. You see, the force will be multiplied. So let us state the formula and let us apply the rule. So as I said before, now F1 in a hydraulic press, the small and the large piston have area 5 and 250. The small area means area 1, which is 5 centimeters square, and the larger area is given to you 250 centimeters square. And if a force of 30 Newton is applied on a small piston, this F1 is 30 Newton, what will be F2? Expect larger force because this is larger area. The ratio are the same. Okay, let us do it. Since pressure 1 is equal to pressure 2, the pressure here, okay, in the fluid is the same as the pressure, because everywhere the pressure is the same according to Pascal rule. Pressure 1 is equal to pressure 2 means F1 over A1 is equal to F2 over A2. From this, F1 we know it 30 over the area 1 is 5. We can ignore the units this time because centimeter square and centimeter square the same, the units is equal to F2 we don't know over area 2, it is 250. Then crisscross F2 times 5. I'm going to multiply these two by crisscross. 5 F2 is equal to 30 times 250. I can write it here up. 5 F2 is equal to 250 times 30 divided by 5 both sides to get F2. So when you divide by 5, you can cancel here again. By 5 1, this by 5 again 5, and there is 0. Then multiply. When you multiply them, 5 times 5, 3 will be 15, and there are 2 zeros at the end, then add them. That's going to be the force. The answer will be A. Look, we applied 13 Newton force. It's very small force when you compare with this one. It's 50 times, imagine it will be. So we can lift a car by applying, or we can stop a car by applying a small amount of force, hydraulic press. So it has a really amazing application, even in our real life activities. Very good. Let us continue to the next question. The next question here, it says, a block of 8 kilogram mass, the mass is given to you 8 kilogram, is moving on a horizontal floor with constant velocity under the action of a horizontal force F. This is the force, the applied force, where the coefficient of friction between the block and the floor is 0.25. Coefficient of friction will be represented by mu, which is 0.25, given to you this one. What is the force of friction? The force of friction Fk that oppose the motion of the block. Force of friction is the same as mu times force normal. That is the formula. But force normal, it is the same as the weight, because the object is on a horizontal surface. So the force normal and the weight are the same. The two are equal. Force normal is equal to weight, which is force normal is equal to mg. Therefore, I can say force of frictional force is equal to mu times mg. So now let us substitute everything what we have. Let's write it here. Force of friction will be, the mu is 0.25. Okay, let us use another page. Don't forget, force of friction will be mu times mg. Here it is. What is mu? It's given to you 0.25. What is the mass? The mass of the object is 8 kilogram. And what about the gravitational acceleration? It is 10 meter per second square. Therefore, as we state, Fk will be mu times mg, which is 0.25 multiplied with 8 times 10. Then this 0 will cancel the point and bring it here. It will be 2.5 multiplied with 8. You have to be good mathematically also, because the point will be shifted once when you multiply by 10. Therefore, 2.5 times 8, 8 times 5, 40. You can write 4 here up. And 8 times 2 will be 16 plus 4 is 20. But there is 1 point, so I have to put the point here. So finally, the answer will be 20 Newton. This is the frictional force. We can get it. The answer will be B. Okay, let's continue to the next question. The next question, it says convex mirror is preferred to use in car for viewing an outside rear phenomena because, convex mirror and concave mirror. So it says convex mirror is preferred to use in a car for viewing an outside rear phenomena because what? How does it looks convex mirror? This is how does convex mirror it looks like. We are using it in car. As you see, we can see the outside environment clearly, and we can see wide areas. So why it is preferable? Convex mirrors are used as rear view mirrors in motor vehicles because, what is the reason? Because, look, it says because what? They form virtual, erect and diminished image respective of distance of the object, and convex mirror helps the driver to view large areas of the traffic. You see, it will help the driver to view large areas. As I said before, look, someone is sitting in the car and he can see even the whole building at the back and every car, as you see here, the wide areas. So what does this statement say? Convex mirror helps the driver to view large areas of the traffic behind him and can easily detect the vehicle coming or running behind him. So now let's get back to our statement. It says convex mirror is why it's preferable. It says it has narrow field of view. No. The image is always enlarged. No, it's virtual, erect, and diminished. It says not enlarged, diminished. It doesn't work. It has wide field of view. Yes, that's correct. And D, the image is always real. It's virtual, it's not real. So that is wrong. The answer must be C. When you go to the next question, the motion of a car from t is equal to 0 to t is equal to 6 seconds on a straight line is described by velocity versus time graph, as shown below here. The velocity is the vertical one and the time is the horizontal. So the total distance traveled in this time interval is. So from velocity versus time graph, how to find distance? Remember the concept what you learned in previous grade level. It says the area under velocity versus time graph, the area, you see, the area under velocity versus time graph equals displacement of the object over a given time interval. So that we need to calculate the area bounded by the line and the time. As you see, this region, the area will give us the total displacement. So what is this? It's a right angle triangle, as you see. It's a right angle triangle. Area of right angle triangle, if you have a right angle triangle, if you are the two perpendicular lines are legs and the longer here it's hypotenuse. So the legs, if they are A and B, so the area will be half times base times height. That is the formula. Half times base times the height. And the base and the height will be the two legs. We can take A and B as a base and area. I mean base and height because they are perpendicular. So this time we have the base and the height in the graph. What is the base? This length from here to here. How long it is? 6. From 0 to here. This is the base. What about the height? This one. From here to here. This is the height which is given to you 16. So the area will be half times base times height, already we said, which is half time the base is 6 and the height is 16. You can cancel as you like. By 2 1, this by 2 8, and 8 times 6 will be 48 meter. So the answer will be C. Let us continue to the next one. It says the temperature of an object is measured to be 113 degree Fahrenheit. That means in Fahrenheit scale. If it is measured using other scales, this temperature is equal to, like we are asked to check how many degrees Celsius this is going to be. It's given to you in degree of Fahrenheit. So how to change it into Celsius and how to write it in Kelvin. So better to change first the Fahrenheit into Celsius and then we are going to change it into Kelvin. First of all, try to remember the formula to change Fahrenheit to Celsius and Celsius to Fahrenheit. Here what's given? Fahrenheit. So we need to change it into Celsius. This is the formula. To find Celsius, C is equal to 5/9 of Fahrenheit minus 32. We have to do it. So the C is equal to 5/9 times, what is the Fahrenheit given? 113 minus 32, which is 5/9 times 113 minus 32 means, 3 minus 2 will be 1, and 11 minus 3 will be just 8. So we can simplify here. By 9 1, this by 9 9, and 9 times 5 will be 45 degrees Celsius. Is there? No, it's negative. In degree Celsius it must be 45, so both doesn't work because there is negative here. Here it's 81. No, so it has to be Kelvin. But how to find the Kelvin? Kelvin is equal to C plus 273. Don't forget this. C plus 273. C plus 273. That is Kelvin means. So the Kelvin will be, we need to add 45 plus 273. When you add them, it will be what? 5 plus 3 will be 8, and 4 plus 7 is 11. You'll have 1 again, 1 into 3, 318 Kelvin. The answer must be D. Okay, let's continue to the next question. The next one, two resistors, each of 6 ohm, as you see here, resistance are connected in parallel across 12 volt supply as shown below. What is the equivalent resistance? So two resistors connected in parallel, and what is the total resistance? That's the question. So in case of series resistor, the total resistor will be, okay, the sum of each. In case of series, this is series, and this one is parallel. In case of parallel, 1 over the total is equal to 1 over R1 plus 1 over R2 plus 1. This is the way how we are going to do it. So we have R1, this one, and this is R2, and we are asked the total resistor. So 1 over R total is equal to 1 over 6 plus 1 over 6, because 1 over R1 plus 1 over R2. This means the denominator is the same. I will add the numerator. It's going to be 2 over 6. 2 over 6 means 1 over 3. This is 1 over R total, remember. So if I flip this, I will flip this one. So R total will be 3 ohm. So the answer is going to be A. The next question, magnets are used in construction of pulleys, thermometers, electric bulb, and batteries. It says this one obviously pulleys. Remember crane. Okay, we are lifting heavy objects up. So pulleys, this is just a matter of concept. Remember and try to revise the uses of magnets. There are lots of uses in case of magnets. The next question, it says a transformer is designed to give an output of 750 volt with an input of 125 volt. If the number of turns in the input coil is 500, how many turns should the output coil have? First of all, this is how does it looks. This is transformer. The image what you see here, it is transformer. There are primary winding and secondary winding. The number of coils in the primary and the number of coils in the secondary, it might not be the same. And the inner part, this part is, we call it transformer core. So if we have primary current, primary voltage, and primary number of turns of the coil, this is a formula. The formula, number of primary, okay, N1 over N2 means N1 means the primary. We can say NP over NS is equal to VP over VS. This time we are not focusing on current, because the question is, our question is talking about the volt and the number of turns. So primary NP over NS, number of coils in the primary over number of coils in the secondary, is equal, like directly, NP over NS is equal to NP over VP over VS. So we are going to apply this formula. So NP over NS is equal to VP over VS. What's NP? Look, a transformer is designed to give an output of 700. This is a primary, I mean the secondary part. This is VS. Let us take out what's given first. Better to extract. So VP is equal to 750 volt and input 100. That means this is the primary, is not, this is the secondary. The primary one is 125 volt, because it says what? The output means the secondary and the input is the primary. And if the number of turns in the input means the primary, so NP is equal to 500. What's asked? NS. So let us apply the formula. NP, which is 500, over NS, we don't know, is equal to NS is subscript, is equal to VP, it is 125 over 750. So what will be NS by crisscross? 125 NS is equal to, by the way, you can simplify it here. Better to simplify there. And let's complete it here. By 5, it will be 25. What about this by 5? it will be 15150. Again simplify by 5. Let's change the color to make it somehow clear. Again by 5, this by 5, 30. Still we can simplify. Again by 5, 1, this by 5, 6. Therefore crisscross. 1 times ns will be ns is equal to 500 times 6. 500 will be multiplied by 6. 6 times 5 will be 30, and 2 zeros will be added there. 2 zeros. That's going to be the secondary. Number of coil in the secondary will be 3000. So these are some of the questions that I prepared almost from the national exam of previous years. Almost we are done, 1 year done, and I'm going to do another year exam paper of physics national exam. So thank you for watching. Don't forget to subscribe, like, and share to your friends. Doing one straight year, like 1 year exam, it will touch many areas. It will be helpful for you. You can write on comment what must be solved, and if you have any question, you can we can communicate on the comment areas. Thank you for watching.